Hello, we welcome your interest in a new way to generate clean, carbon-free energy. I'm Michael, and I'll be your guide throughout this presentation. You're about to be introduced to the most dynamic, predictable, and cost-effective carbon-free system to generate electricity. We call it GMax. GMax Tidal Energy is a utility-scale system generating up to 3.7 megawatts per unit. The presentation ahead outlines the opportunity for a development partnership. Please allot 40 minutes. This is a 6-phase project requiring a $33 million line of credit investment, plus equity options for rollout and exit royalties. A 38-month project lead time will be required to produce the first GMax offshore floating stage unit. Return on investment starts in 32 months upon awarded power purchase agreements from rollout, targeted power authorities, and independent auspices. The following presentation details how GMax Tidal Energy will disrupt traditional and renewable energy methods without artificial subsidy and without carbon emissions. Please click this screen for slides 2 through 28. Upon full review, we're ready to hear your thoughts and questions. The chart on the left is a 1 through 9 Technology Readiness Level System, or TRL. The U.S. Department of Defense uses the TRL to rate and manage an invention's progress in development. TRL 1 reflects ideas in basic concept up to TRL 9, which is an invention's commercialization into the marketplace. We've adopted this system throughout our process to clarify the milestones achieved within our team and for future investors' transparency. The GMax Tidal Energy project is currently at the TRL 6 milestone. This opportunity merges an investor with the GMax technology only 3 steps from commercialization. In the acknowledgments, we've included the Department of Defense information link for further explanation of the TRL system and its importance. Please click this screen for slide 3. GMax Tidal Energy is a utility-scale solution to the problem. Carbon emissions are not Earth-friendly. Scientists can now accurately measure our carbon impact going back thousands of years. From BC times until 1850, human carbon impact was under 200 metric tons per year. From 1850 to 1970, our carbon impact went up nearly 7 times in 120 years due to the Industrial Revolution. Currently, in 2016, we are now near 2 billion tons of man-made carbon impact yearly, as shown on this graph. Studies presently show that the increased carbon impact cannot be sustained. Ocean acidification and altering climate conditions on Earth are all connected to this evidence. Please click this screen for slide 4. Last summer, the island of Manhattan used over 17,000 megawatts of electricity on a hot summer day. Smog was estimated at some of its highest toxic levels ever. Carbon emissions are not people-friendly. Utility plants are the nation's top source of man-made carbon dioxide, CO2 emissions. Additional sources of man-made carbon dioxide are automobiles, coal, oil, gas heat in homes, and powering factories, which are not included in this graph. An average electricity utility plant dumps approximately 3.5 million tons of CO2 into our air every year, and it's rising. In 2011, utility plants in the United States alone emitted a total of 1.7 billion tons of CO2, shown in this graph. Current studies performed in 2016 show that CO2 emissions are linked to asthma and other significant human illnesses. Please click this screen for slide 5. The GMax mission is to generate carbon-free electricity, harnessing predictable ocean tidal currents via an offshore float stage design using linear flow technology. Our goal is to produce thousands of units installed throughout the USA coastline and abroad. Revenue is attained by power purchase agreements from public utilities awarded to the GMax Corporation for low-cost, carbon-free electricity with a lifespan of 30 years. Please click this screen for slide 6. GMax uses linear flow technology to harness the only predictable phenomena on Earth, tidal current. What are ocean tidal currents? Tides are driven by the gravitational force of the sun and the moon. As the Earth rotates around its axis every 24 hours, tides come in and out twice each day, as this illustration depicts. Tidal current describes the motion of water. Tides create a current throughout the oceans, near the shore, and in bays along the coastline. These are called tidal currents. Tidal currents are the only phenomena on Earth that shift in a regular pattern and can be predicted into the future for many years in advance. The GMax Tidal Energy system harnesses these currents to generate carbon-free electricity. Please click this screen for slide 7. The National Oceanic and Atmospheric Administration regularly monitors tidal currents throughout the USA. Documenting tidal predictions at specific locations are vital to all marine-related industries worldwide. This information now serves as an additional benefit for the emerging tidal energy industry. This readily available and cost-free information from NOAA is so significant for tidal energy, it would be analogous to predicting sunshine or wind for their appropriate renewable energy systems. For example, from NOAA's website, the following location at the Brooklyn Bridge shows tidal current predictions accurately for ship navigation and additional use. The breakthrough for tidal energy is that we can harness these tidal currents to generate electricity. Effectively harnessing this immense force enables the following benefits for GMax. Power is able to be generated 16 hours per day, predictably. Such as this example, thousands of additional locations exist 3 to 5 miles offshore that meet and exceed the tidal ranges shown in this illustration. Power purchase agreements could be accurately awarded for 30-year life cycles for each offshore float stage unit. An offshore float stage deck design enables safe access to all components for long-term viability and profitability. We'll get into more detail later on in this presentation. Please click this screen for slide 8. Twin GMax engines harness the ocean's power with linear flow technology. A GMax unit can generate up to 3.7 megawatts. Each unit includes 2 linear flow engines. Each engine supports 215,000 pounds of force every 9 seconds from the moving water current. This force is doubled by having 2 engines. This immense force creates an enormous amount of torque at a very low RPM. The RPM is increased through a planetary gearbox which moves into a permanent magnet generator and creates the carbon-free electricity. Tidal currents can be accurately predicted for many years in advance. Each GMax linear flow engine will generate carbon-free electricity 16 hours per day. A patented connecting structure holds the 2 engines in place in all operating positions, which is a new dynamic in offshore float stage design. Currently, we have built 2 prototypes. The first is the engine, and the second prototype includes the entire connecting structure and movement operations. Our CAD engineering has included marine industry standard practices and materials throughout the GMax innovation. Utilizing an off-the-shelf approach enables accessibility to mass-produced assembly components, which are readily available. This eliminates the prohibitive costs associated with customized components in a one-of-a-kind scenario. Please click this screen for slide 9. Each offshore float stage is an energy plant. A unit can generate up to 3.7 megawatts. Units can be grouped in abundant offshore locations exceeding 100 megawatts. Units are accessible for long-term maintenance above the waterline. Standard industrial marine-grade design enables supply chain accessibility. A GMax offshore float stage will enable accessibility to all operating components for a 30-year life cycle. Swift transport, installation, positioning, and long-term maintenance equates to low operating expenses. Grouping of units for thousands of megawatts per location will result in the lowest operating expenses of any ensemble on the market today. A GMax offshore float stage will eliminate costly foundations, heavy seabed contact, extensive testing, channel blockages, costly underwater maintenance operations, environmental impacts, line-of-sight challenges, spinning turbines, and expensive fixed land acquisitions. Click this link to a video that depicts all movements and operating positions of a GMax offshore float stage unit and her 2 engines. Please click this screen for slide 10. GMax Tidal Energy Carbon-Free Power Plant. Each GMax offshore float stage unit is designed with 2 permanent magnet machine generators. See the specification and illustration on the left. The permanent magnet machine is a state-of-the-art system that is 20% more efficient and 15% less expensive to maintain than a dual-function induction gear system. Dual-function induction gear systems have been in use for many years and have become antiquated due to higher purchasing costs and long-term maintenance protocols. The Switch Company is a leader in the commercial shipping industry, supplying marine-grade permanent magnet machine generators for many years. GMax engineers chose this permanent magnet machine system as our power plant for the main advantages of marine-grade construction, readily available parts, higher efficiency, quality materials, and lower operating expense costs. The switch company's professional engineers have closely worked with our engineers and staff, creating specifications and implementing voltage requirements. Their inherent knowledge and ongoing customer service has been exceptional. This was an important factor in specifying the switch company for the GMax offshore float stage unit and overall systems. Click this link for further details on the permanent magnet machine. Please click this screen for slide 11. The levelized cost of energy is imperative information for any energy plant investment. The next 6 slides clearly show all comparisons to GMax based on their LCOE. The following levelized cost of energy calculation shows that the GMax LCOE is 7.7 cents per kilowatt hour, with capital expenses and operating expenses included. GMax Tidal Energy has the lowest LCOE when compared among current traditional and renewable comparisons. The LCOE is a calculator devised by the National Renewable Energy Laboratory, used to determine the cost in cents per kilowatt hour for electricity plants. Energy developers, investors, and government officials use this calculator for utility scale and renewable energy technology costs per kilowatt hour. The LCOE calculator compares the combination of capital costs, operations, maintenance, performance, and fuel costs for any megawatt output on mostly any size plant. Some of the comparisons have not factored in future replacement, land acquisition, and degradation costs, in addition to geopolitical fluctuations in fossil-based fuels, which are not in this calculator. The GMax team has included all capital expenses and operating expense functions, engineering, procurement, and construction in our LCOE with full disclosure. Please click this screen for slide 12. The following GMax engine output chart was published in May of 2016. The GMax levelized cost of energy for investors and power purchase agreements awarded from utilities is based on these results. Ongoing modifications have increased efficiency by 23% as of 12/7/16. This chart shows the daily output based on a random 1 through 7 knot tidal current location. NOAA manages thousands of documented locations in which tidal energy can be rapidly installed. Please click this screen for slide 13. The levelized cost of energy for GMax is 7.7 cents per kilowatt hour, or when multiplied by 1,000 is $77 per megawatt hour. Nameplate output per average GMax unit location is estimated at 11 million kilowatts per year. The LCOE chart created by the National Renewable Energy Laboratory is a significant resource for investors. The calculator is pre-programmed for capital expenses and operating expense costs of building and maintaining most any sized energy plant. Regardless of the method, be it tidal energy, coal, wind, solar, geothermal, biomass, advanced gas, methane, liquid gas, nuclear, propane, oil, tidal lagoon, hydrodam, etc. The National Renewable Energy Laboratory LCOE calculator is as accurate as the integrity of the cost entries. GMax has entered all capital expenses and operating expenses into the LCOE equation with contingency. The GMax team chose not to add in potential subsidies and tax advantage packages into the LCOE at $77 per megawatt hour. After launching, our Policy Council plans to aggressively pursue every subsidy, grant, and/or tax advantage that exists for our investors and customers' additional benefits. Analysts for investors can review all details and components of the GMax LCOE entries in clear language. Please click this screen for slide 14. The 2 charts before you illustrate a detailed list of the various type of energy methods that exist. The GMax system is compared across the board with traditional and new methods of generating energy. This chart also details the actual comparison costs per megawatt hour, or LCOE, of each type. Tidal energy is the newest method, therefore it is not listed on this chart. In the tidal current space, there are about 10 credible turbine companies and 2 floating stage types coming online. However, the GMax float stage and linear flow technology is the only combined ensemble of its kind to independently generate carbon-free electricity at technology readiness level 6. Not to be mistaken with several wave-type methods, tidal lagoon, tidal pool, or seabed contraptions, which are predominantly at TRL 1 through 3. Although GMax uses linear flow technology and is not a turbine-driven system, two new turbine inventions, which are weeks into the TRL 9 stage, have had extremely successful results. GMax shares this same predictable power thrust in the tidal current energy space. Tidal energy is now on the map thanks to companies like Siemens, Lockheed Martin, Atlantis Resources, Tacardo, Tidal Energy Today, GMax, and others who are raising this awareness. In 7 years, significant investment toward tidal energy is increasing. Because tidal energy is new to the marketplace, as is geothermal, offshore wind, and solar tech, they are considered undispatchable, according to this chart by Natural Gas Technologies IER. Please click this screen for slide 15. Tidal energy is a game changer. Several turbine-driven methods are now becoming dispatchable technologies in a handful of places worldwide. GMax linear flow technology is powered from this identical predictable tidal current resource. The GMax levelized cost of energy is 7.7 cents per kilowatt hour, as shown on the red line of this chart. At $77 per megawatt hour, GMax has the lowest LCOE of any renewable method compared here, and can compete with fossil fuel-based systems without subsidies included. Once a development partnership is reached, the first unit can be operational in 3 years. Please click this screen for slide 16. This chart exhibits the GMax Tidal Energy LCOE as compared to nuclear and carbon-based methods of generating electricity in 2016. The cost is in US dollars per megawatt hour for each method. The LCOE for each method, except for GMax, may or may not include full capital expenses and operating expenses, such as land acquisition, diminishing subsidies, radioactive waste disposal, catastrophe, spillage, new regulations, geopolitical oil price fluctuations, terrorism insurance, and actual operating expense costs. The comparisons to GMax on this page are all carbon-emitting systems except the nuclear method. A 30-year life cycle is the GMax benchmark set for each LCOE comparison. Power purchase agreements structured by the New York Power Authority dictate these options from 10 to 50 years. This chart was created in-house, and comparisons are from third-party accuracy in terms of the conventional methods and information. GMax Tidal Energy shows a lower LCOE than conventional methods of generating electricity, according to the Energy Information Administration, LCOE EIA.gov calculations formula. Please click this screen for slide 17. This chart exhibits the GMax Tidal Energy LCOE as compared to carbon-free methods of generating electricity in 2016. The cost is in US dollars per megawatt hour for each method. These comparisons to GMax are non-carbon emitting systems. Although some methods are at TRL 9, keep in mind they are heavily subsidized by government intervention. Under present administrations that favor carbon-free energy worldwide, some of these subsidies start to diminish by 2018. Investors who rely on subsidies for a profitable bottom line in any renewable energy investment add a significant layer of risk to their portfolio, as the geopolitical climate may change. The GMax team has created an efficient system that is cost-effective without subsidies added, therefore minimizing political uncertainty challenges. In fact, the New York Power Authority asks for all new plant applications to be stripped of any subsidy while in the bidding process. This creates a level playing field for various investor deal transparencies for private equity, bond offerings, etc. It is especially noted utility-scale power purchasers, such as the New York Power Authority, achieve the lowest LCOE pricing in their commercial procurement offerings, prior to subsidies being added, as a new standard pre-bid practice. Please click this screen for slide 18. Each GMax unit will generate up to 3.7 megawatts of carbon-free electricity with patented linear flow technology. This is a significant opportunity for a development partner at Technology Readiness Level 6, with 5 strict guidelines included. Throughout the course of this innovation, such as the patent, CAD design process, litmus testing, and building 2 prototypes, we've developed 5 strict guidelines in respect to all operations in our supply chain. 1. Life safety. Workers who are on or around any GMax float stage can perform 98% of the operations above the waterline in any standard pay grade safe zone. The GMax design includes full cooperation with seafaring vessel regulations and U.S. naval architecture, maritime crew safety laws that preside. 2. The environment. All operations are designed to work in harmony with the environment, both above and below the waterline. Extensive design measures were taken not to disturb aquatic cultures in the process of generating electricity. In addition to practices that go beyond strict standards, it is our responsibility as new energy developers to respect the environment and to prosper simultaneously. 3. Standard equipment. 90% of the equipment designed for GMax in both capital expenses and operating expenses conforms to off-the-shelf technology. Although operating software, some hydraulics, and GMax full automation software will require customization, all parts are readily available from some of the most reputable companies on Earth. 4. Transportation. Any component of the GMax system can be transported using standard practices. On land, parts can be palletized and transported in standard-sized tractor-trailers. On the water, industrial maritime standards meet and exceed the capabilities necessary for GMax operations. 5. Long-term maintenance. Expensive specialty vessels, deep-sea diving, and specialty equipment is not an operating component for GMax. This design benefit keeps the LCOE at the lowest possible operating expense when compared to any seabed foundation application. A standard design that works in harmony with proven industry practices significantly lowers the GMax LCOE for 30-year lifecycle operations. Please click this screen for slide 19. The GMax Tidal Energy team is a choice group of special people. The core team and extended team of professionals have been passionately committed to this endeavor for over 5 years. The following is only a brief description of our credentials and amazing dedication. Upon launching a development partnership, each team member has expressed their continued loyalty in pursuit of GMax commercialization to TRL9 and beyond. Paul DiMaggio, CEO, a successful entrepreneur leading day-to-day operations toward GMax Tidal Energy commercialization and profitability. Paul built his previous company from humble beginnings at the age of 20 to over 300 union construction employees as a subcontractor for New York City developers and hotel maintenance contracts. The business was acquired in 2006. After a short hiatus, Paul then started a commercial wall covering manufacturing company, and 1 year later invented and founded GMax Tidal Energy. Self-funded to date, Paul owns 85% of the GMax shares with no incurred debt. Paul is 54 years old. Angelo Pengue, COO, a proven operations expert, leading vendor performance, scheduling, requisition dynamics, and logistics for turnkey results. Angelo has built custom homes for his family's successful real estate business throughout his life. His ability to get things done is remarkable while respecting the investor's bottom line simultaneously. He is fluent in Italian and Spanish with a keen advantage in solving technology-driven challenges, and he is a strong communicator. Angelo is a 4% with option stakeholder. Angelo is 46 years old. Mark Walls, COE, a highly skilled engineer leading all aspects of the GMax design characteristics, third-party analysis, and finished product approvals. Mark is a true professional in every aspect. His ability to solve complex engineering issues are exceptional. Well-traveled and experienced, his innate ability to create things that do not exist are a driving factor in the GMax innovation. Visualizing components in several dimensions and then translating it to a CAD platform has been a game changer to our progress. Mark is a 9% with option stakeholder. Mark is 51 years old. 27 additional team members share a 2% equity stake. Each committed to a specialty, the GMax project requires highly trained and experienced professionals in singular, detailed aspects of each phase. Please inquire for a list of each person involved and their individual contributions to the GMax innovation. Please click this screen for slide 20. The following chart displays milestones throughout the GMax development. Adhering to the Department of Defense Technology Readiness Level system enabled our team's advancing successes to clearly depict our position. In January of 2009, completion of prototype number 1 took the GMax invention to TRL3 by validating the concept. CAD engineering modules for the basic structure were started. In March of 2011, a provisional patent was filed. By June of 2014, the GMax hydrokinetic invention patent was issued. This patent was for the linear flow technology engine and for the connecting structures combined. In July of 2014, the team commenced with building a lab-sized prototype number 2, which included the entire component package with connecting structures. By May of 2016, prototype number 2 was completed, with 75% of the CAD engineering completed. Modifications in progress have kept pace, now reaching technology readiness level 6. In October of 2016, the GMax team unanimously decided that this technology now requires significant resources to commercialize. The GMax innovation is now ready to present to potential development partnerships based on the previous milestones achieved. Please click this screen for slide 21. GMax is a big investment on any scale, and so is the opportunity. A development partnership with the resources to fund GMax at this pre-launch stage will have a significant advantage. A committed team that is in place with patented technology ready to commercialize is a good opportunity. See the following steps, which categorize the overall scope of work. A full breakdown of each phase in detail are noted in the slides ahead. Step 1 is to finalize a firm development partnership for a $33 million line of credit. Note, funding of all phases 1 through 6 will be allocated from progress requisitions. The entire project scope and goal is to build one GMax 3.7 megawatt unit within a 38-month time frame. Step 2 starts near-shore and offshore locations and acquisitions in approximately 18 months after Phase 1 commences, then begin with power purchase agreement applications. Step 3. Obtain power purchase agreements with authorities, utilities, independents, energy ministers, and renewable energy subsidies not to exceed 19 months after Step 2 commences. Next step, start rollout funding for new unit sales and fulfill primary investor obligations and options. The next section of slides details the 6 phases scheduled for the entire project, including the return on investment. Please click this screen for slide 22. The following is a sample term sheet for GMax investors, return on investment and shareholder stake. All terms are open for negotiation. Return on investment will commence within 38 months. Payments toward all funds received are scheduled for a 5-year debt period. A payment plan agreed upon by both parties shall include an 8% annual interest rate on a 5-year note for a total of $33 million. Terms are open to be negotiated. Interest accrued during the development grace period shall be for 9% total, then added to the principal lump sum. Grace period interest sum shall be combined into the 5-year payment schedule and added as one combined principal. A prepayment penalty of 50% of the interest after the first year of full payments, included with 100% of principal for early loan satisfaction provisions. An equity stake is open for option as guarantor or separate lump sum payment negotiated. Please click this screen for slide 23. GMax Tidal Energy Pathway to Technology Readiness Level 6. Section A, First Phase, starting at TRL 6. GMax commercialization and funding of $4.4 million line of credit. 135-day timeline includes the following. 1. Lease headquarters, office, and warehouse under one roof. 35,000 square feet, 3-year lease with 3-year option, 60-day timeline, or purchase space outright option. 2. Hire fit-out architect and start construction fit-out immediately after workspace acquisition. Set up offices and include all furniture, fixtures, and equipment. A 75-day timeline is allotted for a turnkey occupancy. 3. Interview and gradually hire all office staff. 90-day timeline. Can commence while fit-out is in progress. Energia Works is a qualified sourcing group for engineering, procurement, and construction in renewable energy. 4. 1 administrative person for office manager and executive support. 1 engineering support person for all engineers combined, and 1 project manager support person. 5. 6 people at various skill levels for general labor and prototype setup operations, tech support for website social media as outlined in Phase 2. 6. 5 professional engineers for GMax core design, required for a 36-month period. Mark Walls, Mark Rachel, and other sourced hires. Responsibilities: CAD SolidWorks, ANSYS Network, Maritime Structural, Flow Dynamics, Bathymetry of Natural Elements, CAD Testing, Electrical, Power Plant, software, hydraulics, animations design specialties, etc. 7. 3 key project managers required for a 36-month period. Angelo Pengue, Field Operations, Carl Valentino, Lead EPM, and Brian Chester, PEPM. Responsibilities: managing and procuring all vendors, outsource specialty people, materials, scheduling, adherence to schedule, logistics, tech support, material specifications, and metallurgic test inspections, sign-offs, etc. Coordinate with third-party naval architectural firm in Phase 2 for ocean-faring vessel requirements, maritime certifications, maximum megawatt output nameplate certification, and hull registration of each GMax unit. 8. CFO, accountant costs, tax filing, etc., investor sensitive. 9. Paul DiMaggio, CEO, day-to-day overall leadership throughout phases 1 through 6 toward a revenue-generating and investor-profitable company. 10. The following items may overlap onto Phase 2 and Phase 3 budgets. 11. Engineering CAD software, purchases and subscription costs. 12. Initial marketing materials and presentation materials. 13. Purchase hardware server for in-house crucial network information. All data otherwise will be cloud-based where applicable. 14. Conference room projector and compatible tech applications will be networked to each engineer's desk portal, included with item number 2 fit-out. 15. Safety compliance, property insurance, general liability, and workers' comp insurance. 16. Human resources, employee benefit package, medical insurance, pursuant to all New York, New Jersey labor laws, Right to Work Act jurisdictions, and associated project labor agreements that favor GMax innovation and employee well-being mutually. CEO, office manager, and qualified outsourced professionals will oversee all HR. 17. Legal counsel, attorney for beginning phases and general operations. Please click this screen for slide 24. Section B, second phase start, funding of $5.3 million line of credit, 12-month time frame. 18. Build entire testing platform and custom test pool to enable optimization of a commercial scale device to TRL-8. 19. Hire third-party naval architectural firm for certification and inspection sign-off. 20. Construction of a 35 by 60-foot temporary testing pool with 10-knot water current. Vendor is acquired. 21. Platform construction, including test site portal windows for visual confirmations. 22. Video equipment and above waterline operations. 23. Outsourced audio-visual tech person for all IT. 24. Lighting, HVAC, and MEP furnish and installation. 25. Forklift and overhead lifting equipment necessary to accommodate all operations. 26. Warehouse and lab fit-out, etc. to accommodate all operations. 27. In-house utility bills and all building operating costs associated with headquarters. 28. Travel and presentation expenses for phases 1 and 2. Section C, third phase start, funding of $5 million line of credit, 11-month time frame. 29. Build GMax Prototype 3, testing pool, specifications, and critical information retrieval. A scaled working version to certify engine torque, energy output, harsh element and rough sea testing, debris testing and ice flow simulation, bio and aquatic culture harmony testing. A third-party naval architect will be commissioned for all approvals. 30. Build GMax Prototype number 4, altered from the framework of GMax Prototype number 3. Number 4 will be revised to withstand actual ocean conditions, launched at a specific location for a maximum period of 12 months. A third-party naval architect will be commissioned for all approvals and performance testing. The TRL-8 milestone will be achieved upon successful results within 120 days of the above launch. Section D, fourth phase start, funding of $15 million line of credit, 16-month time frame, the most critical phase. 31. Build and deploy the first full-sized, operational 3.7 megawatt GMax unit. Start TRL-9. Qualified are several domestic and foreign shipbuilding firms eager to take on the GMax rollout project after the first unit is completed. The scope of work includes a fixed guaranteed cost for turnkey completion with owner-supplied permanent magnet generator power plants from the Switch Corporation. Please click this screen for slide 25. Section E, fifth phase start, funding of $3 million line of credit, 9-month time frame. Start ROI schedule for investors and full operations projections. Provide resources for customer acquisition with a sales force of 10 people. Exercise 2-year lease option at headquarters and revise space to a sales platform for PPAs to potential customers and utilities worldwide. Goal: obtain power purchase agreements and location acquisition rights for coastal USA by connecting with utilities, military, and independent consumers of electricity. Section F, 6th phase, start. GMax commercialization, funding a $4 million line of credit, 11-month time frame. Securing mooring rights, PPAs, political policy R&D, grid connection, licensing agreements, entertain new merger and acquisition offers, address investors' exit commitments, full marketing materials and presentation strategy, joint venture council expenses, identifying grant subsidies, identifying rollout funding sources, corporate tax benefits, government-issued renewable energy recs, policy legal counsel for all phases, new patent filings, outsourced transportation, sea transportation vendors, all phases, temporary personnel, general liability insurance, and workers' compensation costs. The rollout program will include purchasing, leasing, and term maintenance contracts depending on each customer's requirements. Our long-term outlook goal is to furnish and install a GMax unit for less than $8 million each. Each full-scale unit is planned to be outsourced for a turnkey bid package. Flexible options may also include licensing rights awarded in a competitive bidding environment. Closing comments. Each power purchase agreement can generate millions of dollars in revenue. Once Phase 6 has commenced, ROI revenue from the first PPA will commence. We can accomplish this within a 38-month period with the right partnership and resources. A strong partnership is our key goal. We've included some links that describe the process and benefits of PPAs from the New York Power Authority for your review. Please click this screen for Slide 26 conclusion. The following GMax Tidal Energy future revenue model is our vision for the rollout. Upon completion of the first GMax unit, our plan is to offer a full service package to customers. The entire headquarters will be renovated and transformed into a central GMax sales platform and begin to develop a customer base. We plan to utilize this platform to demonstrate our system to potential power purchase agreement providers, energy ministers, government officials, and private industry worldwide. Additional options for a GMax offshore float stage have been strongly considered for desalination plants, data centers, heavy construction water pumping, and a host of good ideas sent to our CEO for consideration. At this time, focusing on the following items is imperative, and we'll consider new design modifications at a later date. Step 1. Rollout. Revenue will be generated from the following items: location identification and acquisition services, GMax unit sales and lease agreements, GMax unit installation contracts, electric cable installations, grid connection services, operational services and training, maintenance and repair packages, land-based battery installations, subsidies from grants and policy incentives, renewable energy credit sources, and lump sum purchase order packages. Thank you for your interest in GMax Tidal Energy. Please click this screen for Slide 27 to conclude this presentation and view the contact information for your reply. We appreciate your time and interest in reviewing the GMax Tidal Energy project. Any questions? Please contact Paul DiMaggio to discuss, or email your questions and term sheet offers to the address below. GMax Tidal Energy, Paul DiMaggio, CEO, 104 David Street, South River, New Jersey, 08882. Phone 917-335-1123. P. DiMaggio at gmaxtidalenergy.com. www.gmaxtidalenergy.com. On twitter.com at GMaxTidalEnergy. Upon mutual approval, we'll schedule a meeting to discuss and physically view prototypes 1 and 2, CAD engineering and designs, related intellectual property, vendor groups, licensing, and intellectual property patent information. Thank you from the GMax Tidal Energy team. Please click to the next slide for a review of acknowledgments from the exceptional people who have assisted in this innovation. Acknowledgments. The following organizations in the private and public sector have contributed useful information toward this innovation. More so, many of the people we've come in contact with throughout the process were helpful and insightful. The GMax team would like to thank all of the following people for their focus, time, and diligence. In particular, we want to thank Amit Patel, Carl Valentino, Rutgers Commercial Lab, Stevens Institute, Tatiana M., Professor Wee, Mark Walls, Peter Rindy, PE, Angelo Pengue, Edith at United States Army Corps of Engineers, NOAA, DoD, and Tidal Energy Today for their integrity in the course of their work. The following information sources and web links are active for review. This concludes our presentation. Thanks again from the GMax team.